Hello everyone. In this video or this series of videos, we are going to see how we can convert an NFA to a DFA. So first of all, the question arises as to why do we need to convert an NFA to a DFA in our lexical analysis. So we have already seen that the DFA is used for recognizing tokens, and our regular expressions are used to provide specifications for our token patterns. So for representation or specification of tokens, we use regular expressions, and for recognizing the tokens, we use our deterministic finite automata. But we have also seen that from a regular expression, it is quite simple. Simply by following an algorithm, we can convert it into a non-deterministic finite automata or a NFA. So this process is quite simple. However, for implementation purpose, a DFA is more suitable to convert into a program for recognizing the tokens. Because at the end of it, we want to have a program which can recognize these tokens. So from regular expression, we can have an NFA because that is simple compared to converting it directly to a DFA. And then from DFA, it is easier to convert it into code rather than from NFA. So that is why we need to convert an NFA which we got from the regular expression into a DFA. So uh, for that, we have to understand the main difference between a DFA and a NFA. So what are the differences? Two differences are there. One is the NFA consists of epsilon transitions. That is, in an NFA, you can move from one state to another state without consuming any input symbol. And such transitions are called epsilon transitions. So NFA contains these epsilon transitions which are not present in a DFA. And these epsilon transitions are difficult to put in a program code. The second difference is that in an NFA, for on one single input symbol, we can have multiple transitions from the same state. For example, let us see, let's look at this example. Okay, so I have a state here, 1, and I have another state 2 here. So here, see, on input symbol A, there is a transition from state 1 to state 2. Similarly, again, on input symbol A, I can still remain in state 1. So if you look at state 1, if you have a state here and you have an input here, okay, so state 1 on input symbol A can go to either state 2 or it can remain in state 1 because there are two transitions labeled A from state 1. So in NFA, we can have more than one transition on a single input symbol from the same state. So this is also again quite difficult to implement in code. So whereas in DFA, you don't have this. One state on one input symbol will have only at most one transition. So for these two differences, we have the that is there between DFA and NFA. We have to convert the NFA that we have constructed from our regular expressions to the DFA. Okay, and please keep in mind that an NFA and a DFA are equally powerful. That means if a string is accepted by an NFA, it will be accepted by a DFA also, equivalent DFA, and vice versa. If it is accepted by a DFA, there will always be an equivalent NFA which will accept that particular string. So both are equally powerful. So now what do we have to do in order to convert? We have to do two things. The two things which are different from in NFA and DFA. First is we have to remove these epsilon transitions, and we have to remove these multiple transitions on the single input character. These two will have to be removed. Okay, so we will see how we can remove these epsilon transitions and how we can remove these multiple transitions on same input symbol. Before we end this lecture, let us look at a transition table. This is something that you will need in order to create your NFA or DFA. So let me draw a NFA. So here I have state 0. There is a transition to 1 on A, and there is A and B. 1 on A and B. There is one transition like this, and there is another transition here. This also on AB. There is a transition on B. It goes to state 3, which is the final state, and there is an epsilon transition to 0 from 2. So if we have to we have to create the transition table, it will be something like this. So I have I have the states. So I have state 0, state 1, state 2, and state 3. For every state, you will have one row. And then on this side, we'll put the input symbols. So I have input symbol A, I have input symbol B. And there is also epsilon. Okay, so our alphabet consists of the characters A and B. Input symbols are A and B. Okay, so for every element of this sigma, we will put one row or one column. So now let's see 0 on A. 0 on A, what are the transitions? So 0 on A can go to 0 again by following this transition. Okay, so it will be 0, and 0 on A can go to 1. So 1. Okay, similarly 0 on B can go only to 0. Okay, and 0 on epsilon, there is no epsilon transition from 0, so empty. Okay, similarly let's look at 1. 1 on A, there are two transitions of starting from 1, two arrows starting from 1, which are labeled A. So one is this one and the other is this. So 1 on A can go to 1 and it can go to 2. And 1 on B can go only to 1. And again, 1 does not have any epsilon transition. This is empty. Similarly, let us look at B. 2, sorry, on state 2. On state 2, on A can only go to 2. This is B. This is B, this is B. So on A, there is only one arrow from 2 which goes to 2 itself. Similarly, 2 on input symbol B can go to 2 or it can go to 3. Now look at this 2, there is an epsilon transition. So on epsilon, it can go to state 0. And 3, there is no transitions, no arrows coming out from 3. So this is all empty. So this is called the transition table. Okay, so given any NFA, we have to keep the transition table ready with us so that we can easily convert our NFA to the DFA. So in the next videos, we will see the next other steps for the conversion.